I have made a couple of videos about my Bambu Lab X1 Carbon at this point. That is a 3D printer that I bought through the Kickstarter campaign when it very first launched, and I have been running it into the ground ever since then. I called out some quality issues and modified it a little bit in the first video, then I modified it even more in another one. And now, as of today, it's one of my most used 3D printers. It has almost 2,000 hours on it, which is the most hours of any one machine in my studio at this moment, and it's still not perfect for me. I really have grown to like it and rely on it, and do end up recommending Bambu machines to a lot of people at this point. But for my particular needs, it needs a few more modifications. And that's what we're going to do in this video. We're going to turn it into my ultimate Bambu Lab X1 Carbon. A few of these are going to be some of the most involved modifications that I have made to this machine so far. I don't want to call them upgrades, they're modifications because they are suiting my purposes, but they might not actually be an upgrade for your needs. There will be chapter markers in the description so you can jump to different sections to find what's interesting for you. Alan from the future here. I've got my X1 running sub 10 minute Benchys reliably. Stick around till the end of the video so you can see everything that went into it and those prints going down. We're absolutely going to be making some performance modifications to this machine, but first and foremost, I need to focus on some quality of life improvements and maintenance, such as when you look at this door, it is cloudy, foggy, and nasty, because I mostly these days print ASA filament, which puts off volatile chemicals into the air and puts a film on the inside of this machine. So first things first, I need to clean this thing up, probably adjust the belts. I have over 1,900 hours and I can't remember the last time I did that. And then we're going to install filtration in this machine. Let's pop the back panel off this machine because I'm sure some of you are going to say, well, the Bambu X1 has a filter, and it does. Inside of there, it has a charcoal filter system that doesn't work properly in my opinion. You see, a machine like my Voron 2.4 has the Nevermore inside of it, which draws in air from inside the chamber, blows it through charcoal medium to filter it, and then back out into the chamber to just circulate the air inside of there and filter it as it prints. As we're removing the filter from the Bambu, you can see that the fan blows outside of the machine. In fact, Bambu calls this the chamber temperature regulation fan, not a filter fan. This really doesn't make any sense to me because any material that you're really going to want to filter through charcoal, you're not going to want to take the air from inside of a chamber and blow it out the back of the machine as this setup does. That's only going to reduce your chamber temperature. That's why Bambu calls it a chamber temperature regulation fan. So what we're going to be doing is installing a BentoBox, a community mod originally intended for Bambus but used in various machines at this point. It is an add-on filtration system. It has a HEPA filter to reduce microparticles and charcoal filtration for this machine. It uses a pair of 40-20 fans that draw through a HEPA filter from a robot vacuum through charcoal and then blow it down out the bottom of the housing. It'll make more sense as we put it together and you see it go together. The fans that I'm going to use are a pair of Sanyo fans I picked up off a DigiKey that seem to have a good sound profile while still having plenty of static pressure to do what they need to do, moving air through these different mediums. Assembly of the BentoBox is pretty straightforward. 6 heat press inserts go into the base. Those are the only heat press inserts in the whole setup. For mine, I designed and printed this 85A TPU gasket to isolate the fans and reduce the vibration from them. This is something I'm starting to do with fans now and testing out. The gasket and those get installed into the fan housing, which then screws into those heat press inserts in the base. Then the entire rest of the filter stack, the carbon section, the HEPA section, and the grate that goes on top all get some magnets installed into them. I use the little CA glue as well, and then they just magnetize together, which forms the tower of filtration that is the BentoBox. Now comes time to get this all installed into the X1, which is really straightforward. My particular instance, I had to remove the insulation that I had on the inside wall where this is gonna go, but that's something I put in there, and I drilled a hole in the back wall to pass the wire through. Some folks have squeezed it between the aluminum side panel and the back wall. I didn't want to do that. I fed it through a hole. That way it's just really direct, straightforward, and not squeezed in between the panel. Installation is really straightforward with just a single M3 screw going down into the base panel. I also put a piece of VHB tape on the back side of my fan housing so it's supported against the side panel. Of course, our next step is wiring up the fans, but I want to do something while I have this apart. I designed a handful of 3D printable block-off panels for this machine to separate the print area from the electronics box, hopefully to increase the chamber temperature and reduce the temperature inside of the electronics area. These all mount with VHB tape, and the first one I'm installing does require that the filter housing be removed, as I have done on this machine, so that's not going to be for everybody. But the other ones other folks might find useful. This one is for the big gap that's underneath of the poop chute. It VHB tapes in place and then sandwiches between the poop chute and the back panel to fill that oversized gap that doesn't really serve a purpose. The next one does require that the poop chute's not in place, and then it has to shoehorn up into place, and VHB tapes to the side of the power supply unit, but it has a pass-through for the bed wiring to go through it, and this is the one that's probably doing the most to separate the electronics from the chamber. The last one doesn't even require the back panel to be off the machine. It installs around the left-hand motor and blocks off the vent that brings fresh air from the electronics box directly into the chamber, reducing chamber temperatures. I believe anyway. I don't actually know if these are going to achieve what I want them to. We'll find out later in the video. And there will be links to the STLs for all of these files on my thanks page in the description. Now we can get into wiring these fans up. You might have noticed earlier that I did get 4-wire fans. That was because I'm going to replace the chamber fan directly and use its wiring so the screen controls and G-code controls from the slicer will control my BentoBox now. Previously, when I installed the Noctua fan in this, I did figure out the odd color scheme on the wiring that Bambu uses. It is black for 24 volts, dark gray for ground, light gray is our tack signal, and white is our PWM signal to the fans. With that soldered up, heat shrunk, and all set up, I have a fully functional filter system inside of the chamber of this machine now, and I can control it through the screen-ish. The RPMs on the fans that I installed are higher than the original chamber fan, so I can say set it to 50% fan speed via the screen, and it will set the fans to 50% as I intend, but it will read as 100% because the signal that it's getting is that the fans are running faster than it expects. That's okay. More than likely I'll run it at 100% all the time anyway, but I can still set it to whatever percentage I want. It's just not going to read properly on the screen. That's all. Before I put the back panel back on, there is one more thing in the electronics box. I designed what I'm calling the fresh air fan mount. It is a VHB tape mount that you can put a 4020 or a 4010 fan on. I'm using a Noctua in there that I wired up to the original connector for the mainboard fan, and it draws fresh air through the grate on the back of here to better cool your electronics and get rid of that failure-prone stock fan. Though you could use the stock fan and it would get fresh air through the grate too. With those quality of life mods out of the way, it's time to get into performance. And we're going to start by upgrading the extruder. The extruder assembly on the Bambu X1 ships with hardened steel gears inside of it. The P1 series don't. They come with regular stainless steel gears. So if you're going to be printing abrasive materials often or looking for overall longer service life, you're going to want to upgrade those. Bambu will sell them to you for $19.90. Or you can get these gears from the folks at Fysetc. These claim a couple of things. They're hardened steel and have a nanopolymer coating on them for longer service life. They have helical cut gears for a better mesh and more surface area on the teeth that are engaged with each other, again for better service life and possibly better torque transfer. The hob gear, the part that actually grips the filament, is machined onto the same shaft as the helical gears that mesh together. The idea there is to improve concentricity. It's not an easy word to say. It means they're nice and round and machined together, so extrusion rates should be really consistent with these. The stock Bambu gears, on the other hand, are pressed onto a steel shaft, so there's a chance that they might be slightly out of round from one another, causing slight inconsistencies in extrusion rates as they rotate. Also, the Bambu gears have a plastic arm for the tensioner side, whereas the Fysetc ones have a CNC machined aluminum arm. This does mean that the Fysetc gears are 1.8 grams heavier than the Bambu ones, but I mean, come on, it's less than 2 grams out of the tool head to have overall stronger components. I'm not going to walk you through the install of these gears, as Bambu does have a full wiki about doing it for installing their hardened gears, and it's the exact same process. That'll be linked in the description. I've already run an extrusion consistency print to compare the results before and after this modification. This is by Mihai Design, and it's just a tower with a spiral vase mode print and large layer heights and extrusion widths to just push the extruder harder and see if we get any inconsistencies in our extrusion. So we'll have this for before, and now let's run an after print. I chose to use a co-extrusion silk PLA from AliExpress, figuring the two different colors might highlight the layer inconsistencies in this tower a little bit better. It kinda didn't as far as I can tell, and honestly, our before and after results really don't look that much different. If anything, it might just be a run-to-run variance between the two. Now clearly this is just one consistency test. I'll need more long-term testing, especially to see longevity of these gears, but I don't see a night and day difference running this new Fysetc gear set. That said, if you want to maintain your machine by replacing your gears, or you have a P1 series and you want to upgrade the gears in that, the Fysetc gears can be had for $3 to $6 less, depending where you look, than the Bambu gear set. So you might be getting yourself a possible upgrade, and either way, it's slightly cheaper. Now it's time to really take this up a notch by upgrading Hotends on this machine. I say Hotends because we're going to be testing a couple of them in here. I've previously covered at E3D's factory, you can check out the link up here, the E3D ObXidian High Flow Hotend, and that's the one I know that I want to put in my machine. But in that video, in the comments, a lot of folks were talking about the cheap AliExpress Hotends that are out there that are high flow. So I am going to test that as well. Before we dive into the pile of numbers that I produced from my testing, I do want to break down my thought process on how I tested for flow rate numbers. I use a racetrack flow test instead of the pile of little printed out blobs on the bed and weighing them out individually. Scientifically, I understand why weighing them out specifically like that will get you an ultimate number. But I find that in real world application, when you're layering layer upon layer and you have that pressure difference of pushing down on the layer below it and the filament being drawn behind the hot end, that things are just different. It's one of those places where theory and real world application kind of collide and don't line up in my experience. With the racetrack test, as it travels up, the speed increases, which increases the flow demand on the hot end until we reach a point of either diminishing return or failure entirely. I am using the inbuilt racetrack calibration tool in Orca Slicer, but I've been replacing the model in it with that from E3D, which has overhangs in it. It has these tighter sections where it has to make a lot of quick turns, and I feel like this might have a chance of highlighting inconsistencies better than just a single wall in a straight line will. I use 3 different filaments for my testing. Creality's Hyper High Speed PLA, because folks said they wanted to see a high speed filament used in this type of testing. I also used Polymaker's Matte Polyterra PLA, because that's the material I use the most when I'm printing with PLA, and Polylite ASA, which is the material I use the most these days and what I really wanted to know for my own purposes. Here's the point where probably a handful of people are going to head to the comments and start giving me guff about this. I ran all of my testing at the material temperatures that I usually print at. For the ASA, I primarily run this at 245 Celsius, so that's where I ran my testing at. For the PLAs, I've ran both of them at 220, even though I usually run the Polyterra at 215, because I wanted to just keep a G-code the same between those two materials. The reason for this, I know that I could run, especially the ASA, I could bump it up quite a bit and get better flow out of it. But I want to know what the maximum flow rates are where I'm actually going to be printing things. Here's my thought process. So why do I care if I can get higher flow running higher temperatures on a material when I get poor quality overhangs and bridging and general mushy details on my prints? Sure, I could push things harder, but then I'm going to be fighting cooling issues or running into other problems. I want to know how much flow I get with the materials printing how I print them every day. Simply put, I test the way that I'm going to be printing the material on a regular basis. Let's take a quick closer look at the AliExpress Hotend, because there are a couple things I do like about it and some I don't that people seem to ignore. A lot of folks really like that this has 2 screws and a plate that allow it to add support to the heat break for the heater block to the heat sink. I personally have never had a problem with this on any of my Bambu Hotends. None of them have bent in 2,000 hours of printing and plenty of failures, but if this is a pro to you, it's here. This does have interchangeable nozzles, so you can easily change out to different nozzle sizes, and the one that I got came with these high flow nozzle inserts. And while these are hardened steel, the inserts are copper, and this is a negative to me. If you want a wear-resistant design, pure copper for your high flow is not going to do it. It is going to wear rapidly when using materials that require hardened hot ends and nozzles. I'm not going to get to torture testing this in this video, but check out my other social medias and I'll post when I get around to torture testing that thing, and I'm betting it's not going to last too long, but I could be wrong. Another point about this is the entry to the heatsink itself is tapered so that the filament coming in after the cutter can be guided into the bore of the heatsink, but it's not covered with anything. It's just aluminum. The Bambu and E3D units have a steel cone there to help wear resistance, and after thousands of hours of printing, I've never noticed any wear on those. I question whether that won't be an issue on the AliExpress Hotend. In fairness to the AliExpress Hotend, this will vary depending on what listing you look at, but I paid $18.53 delivered to me in Philadelphia. That came with a heater element, a thermistor, and those high flow nozzle inserts, as well as some thermal paste and a really cheap silicone sock. Now, that is about close to 50% the price of a complete hardened hotend with fan from Bambu, and a quarter the price of the E3D High Flow that doesn't come with a heater, thermistor, or fan. So this is where we really need to break down the results and take a look at how much flow we can get out of these different hot ends on different materials. And immediately the AliExpress hotend clogged. I don't know what the heck happened here. I did have to install the high flow nozzle into this hot end, and the filament path was clear when I did so. I ran the first test, it clogged. I pulled out the filament, pushed it through with a hex wrench, ran a test again, and it clogged again. So I pulled out the nozzle, I ran a hex wrench through the throat of the thing, cleared it out as much as I could, and then I was able to get to testing with it. Some final notes before I show you results. I ran each test with each filament on each hot end at least twice. Some I ran more than that, but what I'm going to show you is the averages of the runs that I got for each filament on each hot end. I'm also not going to the point where I see holes when I measure. I like to err on the side of conservative with my results, so I'm going to the point where I start to see clear physical defects in the surface finish of the prints. That's usually before a hole appears. I would rather find what is a really usable day-to-day flow rate and not overstate some wild marketing number that you folks are then going to be disappointed if you don't achieve. All that said, I was shocked by some of the results that I got. Taking a look at the results from the stock hot end, there are a couple of things that are quickly evident here. One is that the high-speed PLA, the hyper stuff from Creality, it's marketing talk. The Polyterra from Polymaker outperformed it in every single test that I ran. The second thing is that this is the only hot end that I ran Bambu filament through as well, just to sanity check myself, because these numbers were so good that I had to test something else and compare results with some results that other folks had gotten. Simply put, the stock hot end flows better than I have been saying it does for quite some time, and I need to eat crow. But then in comes the high flow variants, and then things get really interesting. Adding the AliExpress hot end to our chart, we can quickly see that it's not doing as well as I would have expected it to. A lot of folks have told me they're getting 40 millimeters cubed per second with the AliExpress hot ends. And don't get me wrong, there's probably multiple versions out there, and maybe one of those is flowing better than the one that I got. Maybe I got a lemon, but the results that I got were only marginally better than the stock hot end. They were better, so if you like some of the options of what this hot end offers for you, it is a flow rate improvement. Then in comes the E3D ObXidian High Flow, and I tested that at E3D's factory. I put it through its paces, and I wasn't blown away by the numbers I got. It was a big improvement, but not even as much as they expected I would get. My testing here, on the other hand, is a whole different animal. If I average out each of the 3 filaments and all of the runs that I got, it adds up to 42 millimeters cubed per second. The answer! Comparing that number to the average of the stock Hotends flow, that is a 60-point-something% increase in flow. Exactly what the marketing material claimed it would do. I'm not gonna lie, I expected the results of the E3D Hotend to be the best of the bunch, but not this good. The testing I did at E3D didn't show me it to be this darn good. I think the Prusament PLA they gave me there to test with wasn't doing them any favors. Now, big asterisk here, your results will vary. From run to run, color to color, filaments will vary. Even if you're running the exact same materials that I am, you might not get the same results. The ambient temperatures might be at play. The heater elements that I'm using in my machine may be a factor. Though I did try 2 different heater elements on the AliExpress Hotend because I assumed maybe the heater they sent with it was weak, but that didn't make any difference. Don't get me wrong, I understand that the ObXidian High Flows from E3D are expensive. They are pricey. I really wish they came with something more for how much you're paying for them, but I see a value here. To me, they are a buy once, cry once product. I should be able to put these in my machines and just run them. With the hardened design and the ObXidian coating, the unleashing of more flow, they should hold up to whatever I throw at them for hundreds or thousands of hours. And I'm going to be testing that long term. Don't get me wrong about that. Though I would highly recommend sticking to quality filaments so you don't have to worry about clogs taking out your expensive Hotend. I do want to note I ran into one kind of big issue with the ObXidian High Flow, and I know ModBot ran into the same problem. I had one test that stopped halfway through with the Polyterra PLA because it was the best flowing material I had here because of a heater malfunction. It just couldn't keep up heating up the filament through this Hotend with the glass top and door open. So a lot of airflow through the chassis for PLA printing, and it couldn't keep up as a result. I closed the door and put the top back on, and I was then able to just run the same G-code and complete the print, but it had maxed out the flow rate by the time it stopped anyway, so it really wasn't a big deal. Does seem like they need a higher wattage heater on this thing, but I don't know how you would achieve that since you can't PID tune the Bambu machine. This is something that E3D and Bambu might need to look into. I do have one modification left before we put all of this to the final test and really push my X1 to the limits. Realistically, testing flow rates probably should have been its own full dedicated video, but the last modification we're going to throw on is the Ben2C 360 cooling duct. I'm generally not a fan of splitting up a single fan into this many paths for air to travel because it's going to take the path of least resistance. But it does seem like they really designed this and put some thought into it. Maybe actually fluid dynamic tested it because the ducting inside of it seems to really guide the air to where it needs to go. Let's get it installed and we can see for ourselves. I did print an overhang test for a before test. We'll do an after once this is in. Assembly of the Ben2C is straightforward and starts with disassembly of the original shroud. You have to remove 4 screws that are holding the ducting to the tool head shroud and then pull it out of a few clips that are on there. Then we have to annoyingly install our own magnets into the Ben2C duct with a little bit of super glue. They are fiddly little and you better make sure you get the polarity right for your cover mount to your tool head. Once you've got super glue on your fingers, you're ready to move on. Looking at the chunky nature of the Ben2C duct, I expected it to be heavier than the stock one, but it's actually just a hair lighter, so I'm making up a little bit of weight that I added with those Fysetc gears earlier. Then assembly is as simple as clipping it into the clips on the tool head shroud and installing 2 of the 4 original screws to hold it on. I wanted to try and visualize the airflow, so we're doing the old, very scientific bowl of water test here. Now, something really interesting popped up pretty quickly when I went to the original duct. It's blowing off center. It's not directly underneath the nozzle where the airflow is focused. when you switch back to the Ben 2C, you actually notice that it's much more centrally located underneath the nozzle. So that impressed me right off the bat. It's clearly making an improvement, at least in the direction of the airflow. Then it was time to run a handful of overhang tests, and I actually swapped back to the original Duct just so I could get a few more results and compare a little more in depth for you. Taking a look at this first test, this was printed in ASA with a closed chamber, and I did dial in settings for overhang improvements on these, but I don't see a big difference between the Ben 2C duct and the stock ducting. Looking at the gray Polymaker PLA prints, once again, I'm seeing pretty much the same thing. Maybe a slight improvement with the Ben 2C, but not anything dramatic by any means. The most dramatic improvement was the first overhang test that I did. The one that I did with the stock duct got knocked off of the bed pretty early on, about halfway through it, and wasn't able to complete. The Ben 2C one also got knocked off of the bed, but way further into the test, and it does seem to be markedly better. For the $30 that this currently runs on 3D Hub Canada, I think this is probably a worthwhile modification if you're trying to squeeze every last little bit out of your X1 or your P1 3D printer. If you're happy with the part cooling as it ships, you're probably not going to care about this. I've always been a little underwhelmed with the part cooling on this machine. Now I'm mildly whelmed with it. So this is something I'll probably be putting on the P1S as well. And with that modification checked off the list, it is time to test my ultimate Bambu X1. And how else would we do that but to print a speedboat Benchy? Following the rules, we're going to see how hard we can push this thing and how fast we can print a silly little plastic boat. Of course, printing quickly begins in the slicer. I started adjusting settings I knew would help me pick up speed, and then I dove in a little deeper, tweaking on different settings and watching the preview for how long the print time said it was going to be. When you're really starting to push speed, slicer estimates, I find, become pretty inaccurate, but they can at least give you an idea. If you adjust a setting and the time goes up, it will mean that your time will go up in the real world. After I got settings really dialed in where I was pretty happy, I wanted a sanity check on where I was headed with it. So I remembered when I recently unboxed the Bambu Lab A1 on my new second channel, MandicReally, the place where I'll be live streaming and doing unboxings in the future, but I was able to go download the Benchy 3MF file for Bambu Lab machines that they had tweaked and tuned to get it fast. I was able to open it up in Orca Slicer and take a look at it to see what they had done. And it just confirmed some of my ideas for where I was headed. For your information, if you want to learn a little more about what I was tweaking in the slicer to get these sub 10-minute Benchies, I am uploading a 3MF file of my slicer profile, what I used to achieve one of these. I honestly don't remember which one or know how fast that particular one will go, but you can take a look at the slicer settings that I changed. I honestly don't recommend using that at all. It's purely experimental. You would need to have the high flow hotend to go with it, and use at your own risk if you want to start uncorking your machine. When I started this project, I knew 12-minute Benchy was probably going to be realistic. I didn't expect to break 10. The first one I printed was 11 minutes and 18 seconds. I dove in, tuned and tweaked and played with things and pushed this machine harder. The fastest one I was able to get, which is slightly more of a Benchy shaped object, is 9 minutes and 31 seconds. I'd say my personal favorite as far as both quality and speed was this one at 9 minutes and 53 seconds. None of these are perfect. Absolutely, the SD card Benchy that comes with this machine, it takes 15 minutes to print, is a better quality one. But I shaved over 30% of the time off from that Benchy to these. And that thought of how much of improved speed on this thing, at the detriment of some quality, is where I'd like to stop and talk about my modifications that I've made here and some final thoughts on high flow hotends and all of this. If you want to see the full 9 minute and 53 second Benchy from beginning to end to prove that it happened with stopwatch and all, it'll be on my second channel, MandicReally, a full video of that print there, link in the description. Looking back here at the end of this project, I am pretty thrilled with where my Ultimate Edition Bambu X1 is at. The hotend is flowing better than I expected it would. The BentoBox charcoal filtration, I'm absolutely already noticing less ASA stinky smell around, which is going to be good for my health working in the studio. All of these Benchys were printed in ASA, and these are fairly short prints, as you saw, but I already saw increased chamber temperatures. So between those baffles and block-off plates that I put inside of here and the BentoBox circulating air, my chamber temperatures are already going up, and that's exactly what I was hoping to see. Now those Fysetc gears, I'm going to have to long-term test those. That Ben 2C duct didn't make a massive difference, but it did improve things. And these Benchys were printed in ASA with the auxiliary part cooling fan at 100%, the part cooling fan on the hot end at 100%, and I'm still fighting cooling issues. So it probably would have been worse if I had the stocked fan duct on here. When I made the initial video about the E3D High Flow Hotend, plenty of people asked in the comments, why would I need higher flow? My Bambu's already fast and flows plenty. And for those folks, I have to say, it's probably a if you have to ask, you don't need it kind of thing. For me, it's going to mean that I can uncork this machine and go faster when I want, but most of the time I probably won't. I run this machine slower than default speeds and accelerations most of the time to improve quality. Now, my testing with these Benchys is showing me I could probably push the speed up a bit on this thing and still get acceptable quality out of it, so I'm going to have to tweak on that. But when I'm behind the 8-ball on a project and I need to get something done, which is way more often than I care to admit, this and the modifications I've made to this machine are going to allow me to just put the pedal to the metal and get things done quicker when I need to. And with my X1 back in its home, I do believe that's where we're going to wrap this project up. You may have noticed that I didn't put X1 Plus on there. There's a reason for that. I never responded when they emailed me about that whole project. Seriously, I applaud what that team is doing, and I will almost certainly install that when it's publicly available, but I was just burned out on all the negative talk around Bambus, and I didn't want to be associated with it. And with that, this is now officially the longest video I have put out to date, so thank you for making it this far. If you did, you are awesome. There'll be links in the description down below to all the products and the 3D printable parts that I showed here. Those are affiliate links. They don't cost you anything more, but they do help me to continue to make videos like this for you folks. Alright folks, I hope you found this interesting. If you did, please drop it a like. Maybe check out the previous E3D High Flow Hotend video that I did, or the Bambu Lab A1 unboxing I did on the Mandic Labs channel over here. Thanks for coming around, folks. Be sure to get subscribed to both channels to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See ya!